In the last session, I explained you what is neural network and what is forward pass, right? What is forward pass? Multi-layer, as part of multi-layer perceptron, as part of multi-layer perceptron, we discussed about what is forward pass. It's something like we have input layer and output layer. In between the input and output layer, we have hidden layers. The input layer, you have the neurons. Each neuron is associated with the columns or the features, the input features. The output layer is nothing but your labeled output feature, right? In between, you have hidden layer. So all the values from your input layer neurons will be passed to the subsequent layer, which is nothing but the hidden layer. And then in the hidden layer, it carries out two steps. One is it is taking the product of the weights of each synapses with the corresponding input values. And then it takes the sum of all the things, okay? And second step is it applies the activation function on the product of the sum of the product of the weights, uh, and the input values for each synapses, right? It applies the activation function. The activation function can be anything. I will discuss about the activation function right after the implementation of the neural network. Okay, I'll show you how to implement the neural network in the Jupyter notebook. Okay, and I just jump into the Jupyter notebook and I will open the same script, John analysis final. 1 second. We have something called a TensorFlow and Keras. TensorFlow is one of the important topics in machine learning and deep learning. So what is TensorFlow? TensorFlow is the one developed by the Google Brain. Okay, it is an open source machine learning framework developed by Google. As part of Google, they have a separate department or team called Brain. Okay, Google Brain. So they were the one instrumental in developing the framework for the machine learning. With this TensorFlow, you can do parallel processing. Okay, you can train your model in a pretty fast manner. So the training time, you can distribute it to various CPUs. For example, in your laptop, you have two CPUs. What you can do is you can train the model in a pretty fast manner. What you can do is you can enable distribution. You can distribute the load across. It's something like, if I ask you to calculate the total values in a paper. Let's say I give you one full scale paper, and in the full scale paper, I have written almost 50 transactions, the invoice related transactions. Okay, what are the products purchased by the customer? Against each product, I mentioned about the amount, right? If I ask you what is the total sales we made, can you sum all the values? And if that needs to be done by a single person, it will take time, right? If I tear that paper into two pieces, two parts, and if I give to two different person, and if I ask them to total it, they can compute a pretty fast manner because two people are working simultaneously to perform the total sales, right? To compute the total sales. Hence, the speed will be pretty fast. So that is the idea of distributed computing. Distributed computing is very much popular. With TensorFlow, you can distribute the load. Okay, you can distribute the load. Okay, and okay, so that is the whole idea of TensorFlow. Okay, TensorFlow is basically a framework. In the interview, they ask you what is TensorFlow. It is a machine learning, open source machine learning framework. Anybody can use it. It's not a licensed one. It's a freeware. Okay, and we have something called Keras. Okay, we have something called Keras. The Keras is an API. Okay, it's a high-level API. Okay, it's running on top of TensorFlow. This script defines a simple neural network model and compares it and then trains it into a data set. See, basically the Keras, I will just show you. I just type here Keras. look here, I have used the way you train your neural network model is slightly different. Any of you have something like MLP classifier, using which, like how you trained your model with other machine learning models like logistic regression classifier and random forest classifier, boost, gradient boost classifier. Likewise, um, you cannot do it with Keras, the Keras. Likewise, you have MLP classifier, using which also you can fit the model. But as I told you, TensorFlow is a very popular framework developed by Google, and the advantage of this one is you can train the model in a pretty fast manner. The reasoning behind this one is distribution. Okay, it has that distribution, distributing the load across the CPUs. It has that capability, and the performance will be faster. Look here, this is what I'm talking about, Keras. Okay, in TensorFlow. So once you install the TensorFlow, how do you install the pip install, right? This is how you need to install the. So here I have commented this one. In your case, you need to uncomment, remove this hash, and then click on this one, run. So it will take time to install the TensorFlow. What is bang? This is called bang. The exclamation mark is bang. That means though you are inside your Jupyter notebook, this command will get executed at your command line. What is command line? This is the one is your command line, right? The Windows command line. Here it will get executed, okay? So I don't have to go to explicitly, I don't type pip install all the things. Inside, without going outside. See, in the real world scenario, you will not have access to Linux system and all, okay? Most of the time, 99.9% you will be working with Linux system, not Windows system. Remember that. In that case, you will not have access to the Linux and all. Okay. Only thing is, if you want to install anything, you can ask the admin to install it. The Linux admin also, they will be installing it for you. It will be already available. But for you people to understand, for learning purpose, you should install it in your laptop. Hence, what you do is you can uncomment this one, execute it, and then people install Keras. Once you are done with this, you can execute this script by selecting all the things, click on run, will give you the version. Okay, so you just check what version of Keras you have installed, what version of TensorFlow got installed. This is a little bit older version. Anyhow, this is just for our version, because the client will ask you, the customer will ask you what version of TensorFlow, and make sure that in the interview they'll ask you what version of Python you use it, what version of package that used, right? You need to know the versions also. Look here, in this case, I have imported the NumPy package. This you know very well. Like how I imported the NumPy package, I have imported TensorFlow. Import TensorFlow as TF. TF stands for TensorFlow, okay? So here, if you see the, right here, I have imported the sequential input layer dense and stochastic gradient descent from these submodules, Keras submodules. So Keras is kind of an API. It's something like, right? See, it's something like your mother is an API for you, right? Your father is TensorFlow, your mother is like API. You cannot ask everything with your dad, right? You'll be rude. Sometimes you'll be very angry. And most of the guys, they're not comfortable directly talking or asking dads, right? If they want anything, they'll, ask their mother to talk to them, because she knows how to talk to her husband and how to convince him, right? And even if he reacts, how to convince him, right? She knows that. So in between dad and son, you need a interface. That's what your mother, right? Your mother is kind of like a garage. You just think it's an API, application programming interface, right? So instead of directly using TensorFlow commands, everything, better we can use the interface. Keras. Keras is pretty simple. All right. So what we will do, that is the reason why we are using Keras here. So in Keras, we have submodules like models, layers, optimizer. So these are the classes that we need to use it to train our model. And here I have used the sequential here. Okay. In this case, what is happening here? So this script, right, it uses the sequential model from Keras. Okay, it is a linear stack of layers. It will stack one after the other. You know very well. In Power BI, sorry, not Power BI. I'm talking about Power BI. See, this is your neural network model, right? This is layer one layer, second layer, third layer. So first it creates this layer, and then it creates the second layer. It stacks one after the other. Okay, so that is what you see here. we are creating three layers. This is your kind of input layer, and this is your kind of hidden layer. This is your output layer. So in the output layer, you need only one neuron in this case. Why? Because you want to predict the probability whether the customer is going to churn. What is the probability the customer is going to churn? If the probability is close to one, that means he is more likely to churn, right? The output is going to be one. Or if you want to predict the class level, yes or no, right? Either yes or no. So in that case, only one neuron is enough. So this is your 8 neurons are there in hidden layer. This is your input layer. Okay. So you have something called a model dot summary. See here what happened. Add dense. Just give me, okay. So in this case, so we are stacking the layers one after the other. Okay, that is called your dense layer. Okay, which is a fully connected layer. Okay. So additionally, we are using something called stochastic gradient descent. That I will explain it later. So that using which we can minimize the cost. Cost is nothing but minimize the error. See, the one of the key objectives of any machine learning algorithm or any deep learning algorithm is minimize the loss, which is nothing but the error. We discussed about the error or residual as part of linear regression. In linear regression, we discussed the error, right? Even in the case of logistic regression, we discussed about error. Okay. So error is nothing but the difference between actual and predicted. That is what we discussed. So the actual and predicted, the difference is lesser, it is better, the model accuracy is good. Instead of saying error, they use some the trending, sorry, they use some fancy word like loss, okay, loss or cost, okay. If somebody says cost, what is the cost of your model? That means they're asking about the error. How much error? What is the error? What is the loss? Loss and cost, they use it interchangeably. Both of them represent the same. In general, they use the term cost, okay. Don't forget it. So in this case, the first line, we have initialized the sequential model, and then it adds the first layer to the, okay, and then we have added the first layer to the model. So here we have initialized the sequential model, and then we have added the first layer to the model. So it is a dense layer with 18 units. The input dimension, look here we have parameter called input dim. So the input dimension is set to the number of input features in your training data set. Supposing if you have 9 columns are there, 9 input features, one labeled output feature. In total, you have 10 columns are there, but one column you need to exclude because that labeled output feature. Remaining 9 columns are your input feature. The input features you need to specify it here. So if you have, let's 16 columns are there, 16 input features, 16 neurons will get created in the first layer, okay? And then we need to specify the activation function. In this case, the activation function, what we used is sigmoid function. The sigmoid function helps us to squash us any value between 0 and 1, okay? And then we have added the second dense layer, with 8 units, okay, 8 units and a sigmoid activation function, okay. And then the third one is the output layer with a single unit. Since it's a binary classification problem, right? We need just only one neuron in the output layer. And also we have used the sigmoid activation function. But here, guys, you remember the input layer and output layer, we have used the activation function sigmoid because it is a binary classification problem, okay? So once we have constructed the model like this, input layer, hidden layer, output layer, the next step is view it, okay, summary, model dot summary. It will give this, not mandatory, okay, but for our thing, right? So how many input neurons got created here in dense one, first one, and second one, 8 neuron, and third one, you have only one, okay? And next one is, and if you see your model dot compile, so this is the one. So you have defined just the layer, but you need to compile it, okay? In this case, we have used the loss function called binary cross entropy. In the intro, they'll ask you what kind loss function. Loss function is nothing but the error, right? To which error function that you used it to minimize the error. So binary cross entropy. Why you have used binary cross entropy? Because it is a binary classification problem. This is a reserved word, guys. Please remember. Again, optimizer. What optimizer we are? This is the optimizer. We are using the stochastic gradient descent. Don't worry about it. I'll explain later. Metrics is accuracy. Okay. Once you define your layer, that is not enough. You need to compile it. But while compiling it, you need to specify what is the loss function that needs to be used. And right, basically we want to the binary cross. And this is how we will calculate the error of your model using which, okay. And then what optimizer we are going to use? Using this optimizer, we are trying to minimize the error, okay. And how do you measure the model performance? Accuracy. Or you want to use accuracy or something else? Accuracy, okay. Next one is model dot fit. So what is model dot fit? What is model dot fit? Fit, what is fit method? So this is the one, the model dot fit. This is the one trains your model using the training data, input, feature training, and label training. Okay. So in this case, you might encounter so you are encountering some new terms, right? Epochs equal to 100, batch size. In the intro, they'll ask you what is epochs and batch size. That I will explain later. Okay. In this case, the values for epochs I mentioned for 100. That means it runs for 100 epochs with the batch size 4. 100 times this model will get trained. It's something like, see, this is one of the student, right? My past batch student, he used to crack the joke, okay? When he asked me to repeat the specific section, I'll tell him, man, I already explained you, right? He says, sir, I need one more epoch. Okay, so that means like how human, let's say you are reading a book, right? Let's say if I give something in a paper and if I ask you to read the movie dialogue, okay, you are reading a dialogue, but only one time if you read it, let's say it's a one paragraph. If you read it, you think you can close your eyes and tell without the help of the paper? No, right? You need to see the paper again. You need to see the paper again. So multiple iterations, multiple epochs. Right? So like human, the machine learning models also needs to needs to get trained with more than one time, right? That is what your epochs. At this moment, you just think that way, okay? Like human, you want to see the same paper multiple time in order to remember, right? In order to understand, remember the context, everything, right? So same way, the machine learning model, if you show the training data only one time, it cannot learn all the pattern in one shot, right? It needs to reread the data more than one time so that the model can learn more patterns. Okay. Next one is pretty simple, accuracy. So here we have used the accuracy. So here, sorry, model dot evaluate. So final step is evaluate. So here, we have with the training data set, we train the model using fit method. Okay. And then we need to check how well my model performs. Now I'm going to apply the model dot on the test data set, right? In the test data set, we have two splits, the input features and the label output features of your test data. You need to pass it as an argument to evaluate. So this is the one will give you an accuracy, something like this, okay? Once you are done with this, you're all set. And again, if you want to see the weights, right? For each synapse, what is the weights assigned by the model, you can see it for that also. Okay, so this is pretty much about, yeah, once you, yeah, okay, yes, Soundarya. So once you train your model, you can obviously, you can use predict also, right? You can use predict. Here in this case, after training the model, I directly jump into the evaluate, okay? And predict function is to predict the test data. So in the sense, unseen data, unseen customers, the telecom customers data. Now I show it to my model to give the predicted target level, whether the customers are going to churn or not. Okay, so that is what. So like other models, we train the model, we can train the model, and then we can apply the train model on the unseen data to make a prediction for the unseen data as well. And also using evaluate, we can evaluate the model accuracy, how well my model performs. This is pretty much simple. But you need to remember here, they may ask you, can you explain how did you construct your model? And they'll ask you other questions like, okay, guys, what is the basis for why you used input layer, hidden layer, and output layer? So why can't you use more than in one input layer? Oh, sorry, more than one hidden layer. Why only one hidden layer? So, and in the case of hidden layer, you mentioned about 8 neuron. Why 8 neuron? So why can't you use more than 8? See, more the neurons, what will happen? Like I discussed in the last session, the more the neuron, right? So let's say all the neurons in your input layer will connect to every other neuron in your subsequent layers. So more the neurons when you have it, the computation, the CPU effort will be more, right? It'll be CPU intensive. It will perform a lot of computation. The more the neurons you have it, right? So hence identifying optimal value for this one is very much challenging. For that purpose, as I taught you hyperparameter, we can use the hyperparameter tuning. That we will see it later for the Keras, how we can do hyperparameter, everything later point out what is the optimal values that you can use it for the hidden layer, right? So input layer, output layer is correct, but the hidden layer number of neurons in your hidden layer, and how many number of hidden layers. Here, if you want to add one more hidden layer, you just copy paste this one. If you add one more thing, that is what your additional hidden layer. Okay. So hope you understood how to implement the the neural network model using the Keras and API for your TensorFlow. I made it pretty simple. Hope even a 10th standard student can understand. And yeah, if you join in between, no, nothing you can understand. Okay.